Hi class, today we are going to be factoring and solving polynomials. So we're going to start off with several different new methods and a review of some old methods. So the new methods that we're going to learn today is something called the sum of two cubes and the difference of two cubes. Then we have a new method called factor by grouping, and then also factoring quadratic style. So when we did factor with quadratics, we had some special patterns. So the review is down here at the bottom. So you have the difference of two squares. So if you had a perfect square minus a perfect square, it factored as a plus b, a minus b, with an example on the side. Then we also had the perfect square trinomials. So if you had a perfect square on either end and the middle term was twice the square roots of the outer ones, then it factored as a perfect square trinomials. So for example, x squared is a perfect square and 9 is a perfect square. So you take the square root of the outer ones, x and 3, so 3x. And the middle term is twice that. 2 times 3x is 6x. So it factors as the square root of the first term plus, because the middle term is a plus, the square root of that one. And likewise, we have the other one. The only difference is you have a negative and a negative. Okay, so now that we've had the review of the quadratic style factoring patterns, we can move on to the new patterns. So for the first one, we have the sum of two cubes. If you have a perfect cube plus a perfect cube, it factors as a plus b, so you take the cube root of each of those, and then you square the first number, and you square the last number, and if it's plus here, it's minus here, and you do the products of the a and the b. So for example, 125 is a perfect cube. It's 5 cubed plus x cubed. So my a is like my 5 and my b is like my x. So when I factor it, it's 5 plus x, so my a and my b. Oops, excuse me. I said x, but I wrote 5. So it's 5 plus x, and then it's a squared. So then it's 5 squared, or 25, and then it's minus a times b, so those two numbers, so 5 times x is 5x, and then it's plus b squared, which would be that number, which is x squared plus x squared. And that is how you factor using the sum of two cubes formula. So next we're going to do the difference of two cubes. It's a very similar formula, except it's a perfect cube minus a perfect cubed, and it's going to be a negative here and a plus here. So the two formulas differ in the two signs right here. Otherwise it's identical. So first off, I don't have a perfect cubed here, and I don't have a perfect cubed here. So it's not a difference of cubes. So the first thing that we need to do is pull out the GCF, and they both have an a in it. So a is my GCF, so this can be pulled out as a times 64 a cubed minus 27. And 64 is 4 cubed. So while I have my a on the outside, it's going to remain on the outside. 64 is 4, and then a, and all of that cubed, minus 27, which is 3 cubed. And I can see that this is a difference of cubes. So 4a is like my a, and 3 is like my b. So then I can go ahead and use the difference of cubes formulas, and I'm going to remember to keep my a on the outside. So it's a minus b, so it becomes 4a, and then it's minus 3. Then it's a squared, so it's 4a squared, which becomes 16a squared, because I'm just squaring all of that, plus a times b, so 4a times 3 is 12a, and then b squared, so it's 3 squared, or plus 9. And that is how we factor with the difference of cubes formula. Okay, so the next method we're going to investigate is factor by grouping. So factor by grouping is handy when you have 4 terms. So first you want to see if there's a GCF you can pull out of everything, in which case we can't. Then we're going to move on to the grouping. So we have 4 terms, which is an indicator that we can use factor by grouping. And I'm going to group the first 2 terms and the second two terms. And I'm going to pull the GCF out of the first two terms. So the GCF of the first two terms is x squared. So I'm going to factor an x squared out of it. And when I pull an x squared out of the first term, I'm left with x. And when I pull x squared out of the second term, I have minus 2. And I double check. If I distribute this back in, x squared times x gives me x squared, and x squared times negative 2 is a negative 2, x squared. So then I'm going to look at my second two terms here, and I'm going to pull out the GCF. And I'm going to pull out a negative 9. Now when I pull out a negative 9, I'm left with x, and negative 9 times negative 2 gives me the positive 18. Now the reason I chose to pull out a negative 9 instead of a positive 9 is because your goal is to make these two things, these two factors, identical. So by pulling out a negative 9, I was able to get a negative 2 here, which gives me a negative, or a positive 18. So factor by grouping, I'm going to rearrange my groups. X minus 2 is one group, so it's x minus 2. My other group is x squared minus 9. And it doesn't matter if x squared minus 9 comes first or x minus 2 comes first. But in reality, it's the same thing, it's just rewritten in different ways. See, I'm going to take my x squared, and I'm going to multiply it by x and minus 2. And down here, if I'm going to FOIL it out, if I did my first, I get my x squared minus my x squared times x squared times x. And if I do my last x squared minus 2, it's just like up there, x squared minus 2. And here, if I were to distribute it back in with the negative 9 times x and negative 9 times negative 2, that's like my inner, here, negative 9 times x, and my last, negative 9 times negative 2. And it's the same thing, just a rearrangement. Now you check, can it be factored any further? And in fact, this is a difference of squares. You have a perfect square and a perfect square. And remember, this factors as the square root of this minus the square root of this times the square root of this plus the square root of that. That's a difference of squares. So this factors as x minus 3, x plus 3, and then again we have our x minus 2 that we're going to carry down. And that is factored completely using the method of factor by grouping and then difference of squares. So there's one more factor by grouping example, and this has 4 terms again, which is also an indicator, try factor by grouping. There's not a GCF I can pull out of all the terms, so I'm just going to move ahead to grouping my 2 terms and pulling out my GCF. So of the first 2 terms, I can pull out an x squared. So I can pull that out, and I'm left with a y squared minus 3. And if I distribute that back in, I get what I started with. Now again, I'm going to pull out a negative 4, and when I pull out a negative 4, I'm left with y squared and then a minus 3, because negative 4 times negative 3 is a positive 12. And then I'm going to regroup them. X squared minus 4 is one group, and then y squared minus 3 is my second group. Now this is a difference of squares, so it can be factored as x minus 2, x plus 2. But y squared minus 3 doesn't factor so nicely. So I'm just going to leave that as y squared minus 3. And that is how we factor by grouping. And then again, use the difference of squares formula. So now we're back with 3 terms. And this is where we're going to factor quadratic style. This factors just like x squared plus 4x minus 21. And we're going to find 2 numbers that add to be the middle term, which is a 4x squared, and 2 numbers that multiply to be the product of the outer 2 numbers, so minus 21 x to the 4th. So if we're adding things that add to be x squared, I know it's going to be an x squared and an x squared and an x squared and an x squared. And I just have to think of the numbers that multiply to be 21 and add to be 4. So if it was a positive 7 and a negative 3, then those would work out. So positive 7x minus positive 7x squared minus 3x squared gives me a positive 4x squared, and 7x squared times negative 3x squared gives me a negative 21x to the 4th. Remember, we're adding our exponents. So we put our 2 terms in the diagonal, so you have 7x squared negative 3x squared, and you put your first term in the first box, and your last term of negative 21 in the last box. And we pull out our GCF. So when we pull out the first row, they both have an x squared in it. In the bottom row, they both have a 7 in it. The first column has an x squared, and the last column, remember because it's a negative here, we're going to pull out a negative, and they both have a 3 in it. And then multiply it out to make sure you get what you started with. X squared times x squared. I said write the first number there. That should be an x to the 4th. The first term is x to the 4th, so it should be an x to the 4th. So when we're checking, x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. X squared times 7 is 7x squared. And 7 times negative 3 is negative 21. And when I add the diagonals, I get a positive 4x squared, which is what I started with. So this factors as x squared minus 3 times x squared plus 7. So x squared minus 3 times x squared plus 7. And I don't have any special factoring pattern, so this is factored as much as possible. But if it was x squared minus 4, then we'd go ahead and apply the difference of squares formula. So for this one, when you have two terms, I want you to think if it's the sum of cubes, difference of cubes, or difference of squares formula. Well, I don't have anything cubed. I don't have a GCF I pull out. But I can see that this is a perfect square and this is a perfect square, and it's going to be a difference of squares. So 25x to the 4th is really 5x squared squared, so here's my a, minus 6 squared. So that's my b. So I have a perfect square, because remember you distribute your exponents, minus a perfect square. So this factors as 5x minus 6 times 5x plus 6. So that's when you have a perfect square minus a perfect square. Oops, sorry, it's 5x squared. And if I were to FOIL this out, I would get the same thing because the outer and inner terms drop out. Now, can either of these be factored further? No, because neither of them is the sum of squares or a difference of squares, or a difference of cubes or sum of cubes. So let's go ahead and move on to the next problem. So for this first problem, I noticed that I have a b squared in all of my terms. So I have to first pull out my GCF, which is a b squared. You always need to pull out a GCF first. So when I pull out a b squared, I'm left with a squared minus 8ab plus 16b squared. So once you pull out the GCF, then I notice that I have a perfect square on either end. And I want to recall that you have the special factoring pattern that I wrote down here. So if you have a perfect square and the middle term is twice the products there, it factors like this, which we showed on the front slide. So the square root of the outer term is a, and the square root of the bottom term, or the last term, is 4b. And the middle term is in fact twice the product of the square roots of the first and the last term. So since I have this special factoring pattern here, I know that factors a minus b quantity squared, where I have my a, I have my b, and then it's going to be squared. So I still have this outside, my b squared. And then this factors as a special factoring problem. So I have my a, which is the square root, which is a. Then it's going to be minus b, which is the square root of your last term, which is square root of 16b to the 4th, is 4b. And I have my parentheses in the wrong spot. I fixed my parentheses. It's 4b squared squared, because I'm going to distribute my square to my 4. And 4 squared is 16. And I distribute, so I multiply my exponents, and it would be b to the 4th. So 4b squared is the square root of my last term. And there you have it. This is factored as much as possible. Don't forget your squared on the outside, because it's squared. So here we're going to solve. So I'm going to pull out my GCF, which is a 2y, and I'm left with y to the 4th minus 9 equals 0. So since I have the product of two things equaling 0, I can set each equal to 0. So I set each term equal to 0, and this first one, when I divide by 2, I get y equals 0. The second one is a difference of squares, so I can factor that. So I factored it using the difference of squares formula, so now I can use the zero product property to separate and set each equal to 0. Then I can solve by adding 3 to the others, and then taking the square root of both sides. Remember plus or minus the square root of 3, and do the same thing to the other